In this short video, I'm going to do a deep dive on a new ActiveScale deployment option, a redundant array of independent libraries, also known as the Quantum Rail architecture. The Quantum Rail architecture allows multiple libraries to work in an array fashion, which increases performance and redundancy by using multiple libraries in parallel as opposed to using a monolithic tape library, and is greatly enhanced by Quantum's two-dimensional erasure coding when deployed with ActiveScale Cold Storage. Recently, Quantum introduced a cold storage class for ActiveScale, and that cold storage class is based on tape, so we can take advantage of the superior economics that it provides. So ActiveScale now has two storage classes, an active storage class based on hard drives and a cold storage class based on tape. And the two storage classes are seamlessly integrated into the ActiveScale namespace, meaning in a single bucket you have direct access to all objects regardless of whether they reside in the active storage class or the cold storage class. Now it's easy to imagine using a monolithic tape library behind an object storage system and then providing some mechanism to archive objects to tape. Although using a single, very large tape library may provide the desired capacity, it does, however, severely limit performance, availability, and durability. The Quantum Rail architecture does not work like that. It is unique, and it works like this. Within an ActiveScale namespace, you have both the active and cold storage classes. And Rail is the idea that the cold storage class is made up of multiple, smaller, independent libraries working as an array. And with Quantum's 2D erasure coding, the resulting multi-terabyte segments can be streamed in parallel to these independent libraries. And what that does is simultaneously maximize data durability, data access performance, and storage efficiency. And Rail does not need to be big. You can start with as few as 2 libraries, and grow the array very large with no upper limit on the number of libraries in the array. So let's take a closer look. Here we have a Rail with 6 libraries participating in the array, and these libraries are independent. They each have their own robotics, their own tape drives, and of course, their own tapes. The first advantage here is parallelism. The ability to leverage all these resources in parallel gives ActiveScale Cold Storage an incredible performance advantage. And with ActiveScale's 2D erasure coding, which produces multiple segments, the Rail architecture allows ActiveScale to spread those segments across libraries in parallel, which results in better performance and durability. So objects are secure and remain accessible in the event of a robotics failure, a drive failure, a tape failure, and even an entire library failure. And because ActiveScale uses 2D erasure coding rather than a multi-copy approach, objects are protected even in the event of multiple library failures. Rail is flexible. You incrementally add libraries as performance and capacity needs change. And this array of libraries can be in the data center of your choice. Or for ultimate protection, in a 3GEO deployment, a single array of libraries or a single Rail can be distributed across multiple data centers. Now let's review some of the benefits Rail provides. It enables ActiveScale to efficiently leverage the economics of tape for its cold storage class, which is fully integrated into the ActiveScale namespace, and with 2D erasure coding, Rail provides superior protection and durability without the expense of a multi-copy approach. Rail allows incremental and flexible expansion, and that expansion increases both performance and protection. For more information on ActiveScale Cold Storage, visit our website.